to take this opportunity. I'd like to take this opportunity to welcome you to our second webinar in the series at CAA's Launch and Learn, Climate Change, Emerging Risk and Opportunities. In our first webinar, we focused on transition risk and how it can be modeled. If you missed it, don't worry. You can find it on the CAA's YouTube page. You may also find on our page a video produced by the team, which is an introduction to the risk of climate change. Now, today, for this webinar, we'll be focusing on the physical risks associated with climate change. The physical risks associated with climate change are evident, especially to us in the small island nations. And we've seen an increase in the frequency and severity from weather-related disasters. Our first speaker, Dr. Jamaica Campbell, who is a climate studies specialist and lecturer at the Department of Physics at UWI Mona, will take us through some of the changes that have been observed in the weather patterns in our region, some projected impact due to climate change, as well as the potential impact on the people of the Caribbean. Now, many tools have been developed to mitigate the financial losses from these climate disasters and to protect our economies. One of these tools are cat bonds, and Jamaica launched a catastrophic bond last year. And our second speaker, Jose Angel Villalobos, who is the Senior Financial Sector Specialist at the World Bank in their Crisis and Disaster Risk Finance section. He will give us an overview of the cat bond and share with us some of the details that went into consideration developing the catastrophic bond for Jamaica. Feel free to post your questions at any time. However, the answers for the questions will be addressed at the end of the two presentations. I'd also like to take this opportunity to invite you to join us for the CAA's annual conference. This year, it will be held in Barbados from December 7th to 9th. However, if you're not able to join us face-to-face, you may join us virtually. For more information on that, you can visit CaribbeanActuaries.com, where you can register and find out more. The webinar will be recorded and uploaded to the CAA's webpage or active view. This may include the questions and chat responses. So by registering for this webinar and attending this session, you have given the CAA permission to use any text, photos, or videos taken during this virtual session. Now, without further ado, I turn you over to Dr. Campbell as he leads out in our first presentation.
All right, I'm hoping you are hearing me, and I'm hoping you are seeing me as well.
We are hearing you and we are seeing you.
All right, so I'm pretty. All right, so just give me a second to just engage sharing, please. There we go. And so, all right, so first and foremost, please just call me Jay, please. You can leave any honorarium, any names off after that, just please call me Jay. I like an open setting, please feel free to ask any questions you want to ask. And I will try my best to take as many of your questions as I possibly can. All right, so I'm about to share my screen. And you can let me know if you're seeing it.
Yes, we are.
All right, so in the next, Rohan, half an hour, 20 minutes?
Yes, around that.
All right, so for the next 20 minutes to half an hour, I'm actually gonna try my best to engage you in climate change on the Caribbean. I'm gonna discuss some of the broad implications, but I like when things are a little bit interactive, so forgive me if I do this. I like starting things off with a quick question. So my quick question to you is, within your own sector, within your own area of expertise, and just think about it for a second. If you were to pick any one of these climate variables, temperature, rainfall, sea level rise, or even wind, any one of these, and I'm actually forcing you to use the chat now a little bit. If you're to use any one of these variables, which one of these variables would you say would have the greatest impact on your sector, greatest impact on your field or your area of expertise? Just take a few minutes to think, a few seconds to think about it, and just think about it. Is it temperature? Is it the rising temperature that's creating the greatest impact? Is it the rainfall, be it absent or in too much? Is it the overall issue of sea level rise? Or is it wind? And by wind, we're not just talking about wind that's used to generate solar energy. We're talking about extremes of wind. We're talking about, for us, that's 6 months, possibly 6 months of the year when we talk about hurricanes. So which one would you say? And I am not getting responses.
Well, I would quickly say wind, thinking about hurricanes and the impact that would have on property. So we might be thinking about insurance claims and so on.
All right. So you're not, again, and I'm going to say, when we try to sometimes ascribe a rationale, we try to pick one thing and we try to work at that one thing. And sometimes it's easy to pick one thing, but within this overall climatic space, it's very difficult to do that, because in essence, you're talking about an event that's possible once or multiple times over the course of 6 months. But when you think about rainfall, the absence of it for the entire year can be far more devastating than a single night's event, because it could have multiple impacts on multiple sectors. And again, I'm not saying any one of these is more important than the other. What I'm saying is climate is so interconnected that it's hard to separate out any one of these per se without actually involving the others, because you can have your slow onset events, right? And note, we're not just talking about events that occur within the Caribbean. We're talking about slow onset events anywhere. And in general, in terms of the climate spectrum, you can have your extreme weather events, be it your hurricanes, your flooding, drought, and drought itself can be a slow onset event. It can take many months for you to feel the effects of an overall drought, and drought can be classified in many ways. It could be meteorological drought, it could be agricultural drought, or it could be hydrological drought, and each has a different impact on sectors, right? So with that said, we've set the stage with that big question. We've set the stage that in essence, you can talk about temperature, you can talk about rainfall, you can talk about sea level rise, you can talk about wind, you can talk about relative humidity. But in essence, it set the stage that different climate factors impact different sectors in very different ways. You could talk about health, you could talk about wildlife, you could talk about agriculture, coastal areas, forests, the built environment. Different things have different impact on different areas within the climate frame. I like taking that wildlife example, and at the end of this presentation, I'm going to give you a key wildlife example that, for me, kind of sets a stage that we sometimes, take for granted or overall environment, right? So from that quick question, I'm saying that it gives us an opportunity to plan and prepare. It gives us an opportunity to prioritize, and it gives us an opportunity to explore possibilities. So within that framework, the entire presentation, I call it the 3 Ps, or some people say 4, it gives us the ability to plan, prepare, prioritize, and explore the possibilities. What I mean by that is this: we're going to examine some global changes. And remember, even in some instances where we would not have experienced within the region, within our own nations, experienced changes at a particular level, there are global changes that indicate that our changes are not far from coming. It may not match what we see at the globe, but there is some change coming. We'll do some regional changes and regional analysis and work ourselves from that point into looking at some local examples. And from the local examples, we'll actually talk about some future projections. So we will do some hindcasting, looking at what the changes have been so far. And we'll also do some future casting, which is actually taking those climate models, those mathematical models, and project into the future plausible climate states for the region, right? So globally, we're going to start out first with what we know. And in a sense of starting out with what we know, we're actually looking at data that's been collected, data that's been analyzed, and information gleaned from that data and what it suggests. The starkest image I can actually put to you is this one. This one actually says to you that global temperature and carbon dioxide concentrations have been increasing. The carbon dioxide concentration you're talking about is in red. The temperature changes, and you see temperature there. It's the temperature that we're talking about in this instance. It's called a temperature anomaly diagram. So you take the mean state of the temperature, the climate in terms of temperature, and that mean state we established between 1880 and about 1910. And that's mean state, it's about 15.6, 15.1 degrees, somewhere within the 15-degree range. And what we do is that you take every year's temperature average temperature and minus from that mean. So you expect some years to be a little bit warmer, some years to be a little bit cooler. But somewhere after the 1930s, 1940s, there seems to be a sharp rise in your carbon dioxide concentrations and also a sharp rise within your temperature. If you are asked to give a single sentence that details the relationship between temperature and carbon dioxide from this graph, I will tell you they have a relationship that's sometime-ish. And even though it's sometime-ish, they never drift too far from each other. They are seemingly, the temperature is going up, the carbon dioxide is going up, and the temperature seems to be oscillating around the increases in the carbon dioxide concentration, right? Because some years you're expecting warming and some years you're expecting to be cooler years, but the cooling after time does not oscillate around that 0 point that we expect the cooling to be around. So we're expecting that everything within here, this minus plus or minus 0.1, is that nice place to be. What we've seen is an increase of about 1 degree in excess of 1 degree Celsius, or at much 2 degrees Fahrenheit over the last century in increases, right? There's some that argue that increases we've seen so far are not due to are not due to human effects, but are in fact due to natural effects. This diagram was taken from the Intergovernmental Panel on Climate Change, AR6 Working Group 1 report, and it actually details to you that here you're looking at warming, observed changes in warming, right? And you're looking at reconstructed temperatures, and that is showing you what we expect in hindcasting. When you take ice cores, tree rings, you use climate models, and you do hindcasting for the overall temperature. We're saying at most, in the worst case, the Earth was about 0.5 degrees warmer. Now we're looking at the globe exceeding 1 degrees warmer in totality. So that's giving you where the globe is going. And they also split it out where they actually said, well, what happens if we remove all of the human activity from this overall space? What happens? What can we say would have been the effect on the climate scale? And when you remove all of the human effect, the simulation said that the temperatures would be round about here. The moment you include the human effect, the simulated temperatures match back to the observed temperatures. So it means that the human enhanced effect, the human effect, that ability we have of giving off greenhouse gases is what is driving the latest warming we're seeing. Is everybody still with me, please? Just checking.
Yes, Jay. Yes, Jay.
Anybody?
Yes, we're still with you.
Good. All right. So when we split out the years and looking at the years, and there are some key things that you can look at here, right? You may see, I may talk about a temperature rise and it may not seem that significant to you. But look at this diagram. We look at 160 years of data. And when we look at 160 years of data, we're trying to pick out the 10 warmest years. And in attempting to pick out the 10 warmest years, there's some key things to note. If we included 2020 and 2021, looking at the first diagram, all the warmest years would have been since 2010, which means the last decade we went through would have been the warmest decade on record. Now, there's a point within that decade where 2014 was the warmest year on record, and then 2015 came, and that was the warmest year on record. And then 2016 came, and that was the warmest year on record. So we went through a period where year after year after year, we have just been getting warmer and warmer and warmer, right? So there are some that says the 2010s were just a warm decade. So we don't just leave it to the yearly analysis. And when you look at the outside of the yearly analysis, and the research shows that somewhere after the 1950s, every decade after the 1950s was warmer than the decade before. So you notice 1950, 1960, 1970, you're going up. And then you make a massive jump to the 1980s. Then another jump to the 1900s and the 2000s. Then a 0.4, that's the largest jump in average temperature from one decade to another. That's about a 0.4, 0.5 degree increase in global temperatures in going from the 2000 decade to the 2010 decade. Right? There are some things that we talk about and we look at it in terms of the overall globe. And when we look at it in terms of the overall globe, there are some key things to note. And I'm pulling out here something from June to August in 2022. And you're looking at surface temperatures, where surface temperatures were about 0.9 degrees above what they were for the 20th century average of 15.6 degrees Celsius. It tied with 2015 and 2017 as the fifth warmest year on record. And this is looking at 143 years on record. So again, you're looking at us going towards, you're looking at it, the dark red means record warmest, right? The blue means record coolest. There is not that matching record cooler than when you look at it. Overall, the globe itself is getting warmer. Now, there's some key things to note. When we talk about sea level rise, it tends to be in the vernacular and in the spin that, sea levels are rising because of the melting of polar ice sheet, Greenland ice sheet, polar ice caps. There's a melting of frozen and glaciers. However, if I challenge you to put a pot on the stove and fill it to the brim with water, and you apply some heat source to that pot, what happens is that before the water starts boiling, water is going to spill over onto the stove. If you take a cup or a pot and you stick it in the fridge, when the water gets frozen, the ice is a little bit above the brim of the cup. Because water is one of those key things where once it's heated above a particular temperature, it expands. Once it's cooled below a particular temperature, it expands. So some of the sea level rise we're seeing is not just due to the melting of ice or frozen rivers or lakes. It's also due to the thermal expansion of water. And what we've seen is that early 1900, we saw that sea levels were increasing. Global mean sea levels were increasing by about 0.6 millimeters per year. Between 1940s and between the 1930s and 1992, there was a doubling of that increase, where it increased, the previous was 0.6, this is now 1.4 millimeters per year, more than doubling. And this is a split because there are two separate data sets for the end of this data set. And this is work et al. 2015. And it showed, when you're looking at it, again, it's almost a doubling. If you look at average, take an average of those two data sets, it's a doubling again for that 1993 to 2015 period. And it may not seem significant, but you take a millimeter over the course of 100 years, right? And it's starting to get to the point where it may affect you. A nice way to think about it is, if you think about seawall defenses, they're static things that are built. And if you have any area below sea level and sea levels start rising, it immediately means that you now need to start building a higher flood defense. It immediately means that any change in surge pattern or any change in high tide could very well crest your seawall defense. And if you now need to build a higher seawall defense, it simply means that the pumps or anything that you're using to pump water out of your city, as in the case of Guyana and in some instances, Belize City, you are having to pump water at a higher level. And so the inputs for pumping is also, or the pumps that you may need to use are now more powerful, required to be more powerful, right? The changes that we've seen in our climate are not just limited to the physical space. You can also see a spread in tropical diseases. And there are some interesting metrics that are actually at play here. There's some work done in the region that actually attempts to tie changes in temperature and rainfall patterns to the incidence or onset of dengue. And so when you talk about it from that point of view, there are a few things that we get. So many tropical diseases such as malaria, Chagas disease, and even dengue are transmitted to humans via mosquitoes and other carriers known as vectors. These vector-borne diseases continue to have a major impact on human health, especially within the developing world, where each year more than 1 billion people become infected, and around 1 million of these people die. In addition, this is the key part, around 1 in 6 cases of illness and disability worldwide arises from these diseases. So in essence, if you think about it, we tend to think that these are diseases. They're not necessarily fatal if treated properly, but they can also lead to disability, right? When you talk about, global warming and climate change, it has allowed the mosquitoes, ticks, and other disease-carrying animals to spread and adapt to different seasons and areas that they were not before. And so even across Europe, there's been accompanying outbreaks of dengue fever in Croatia and malaria in Greece, and even West Nile fever in Southeastern Europe, and chikungunya in Italy and France, right? In a lot of instances, this may only be the tip of the iceberg. And so when you're looking at it, it may be the case that you may actually, these areas, instead of just having dengue for a small season, may end up with dengue all year round. Right? So again, we've seen what has happened with the globe. And there's an old African proverb and there's an old Jamaican proverb. And the old African proverb says, if a snake bites my neighbor, I too am in danger. So we've seen what has happened with the globe. And so within the region, it gives us the ability to plan and prepare for our own changes and what other changes may exist. So regionally, what have we seen? When we talk about the Caribbean's past, right? Caribbean, that's a large area. And when we talk about the Caribbean in terms of climate context, we tend to include Guyana and Suriname as well. And we tend to include Belize as well. All right? So when you talk about it, we can't say there's a significant trend or decrease in rainfall. When you're looking at it, there's a significant decadal variabilities exist, where you have groups of wet years and you also have groups of dry years. So you can really realize that in some instances, there are groups of dry years, especially in around the 1960s and 70s, right? And there's some significant year-to-year variability. And it also, in essence, mirrors some other findings from outside of the region. We can't say that is a statistically significant trend in rainfall, right? The Caribbean is not a contiguous zone, which means everywhere in the Caribbean doesn't change in the same way. So you can't have a one-size-fits-all for the Caribbean because not every area within the Caribbean varies in the same way. We have distinct sub-regional zones. And within these distinct sub-regional zones, there's some key things to note. Right? One, zone 4 tends to have a downward trend. And we'll walk through that downward trend for zone 4. And when you look at it, it's indicating that warmest points in the Caribbean exist towards the west, right? And the warmest points in the Caribbean existing towards the west, cooler parts exist heading towards the south. We can't say anything about rainfall for some areas. If you're talking about anyone, there's a slight downward trend in zone 6 and zone 5. And remember, zone 5 contains much of the eastern Caribbean stretching towards Trinidad, all the way down to Trinidad, and zone 6 contains Guyana and Suriname, some station points of Guyana and Suriname, right? Over temperature, there is a clear and defined trend for temperature. And this clear and defined trend means that it's consistent with other studies that see this dominant upward trend. The increase far exceeds that of natural variability. And in instances, it's approximately 0.9 degrees Celsius per decade. Or when you're looking at it, that's nighttime temperature, daytime temperature. And for nighttime, our nighttime temperatures have been increasing far faster than our daytime temperatures, right? And you can see that, again, it's not uniform. So the rate of warming for the Eastern Caribbean far exceeds the rate of warming for the Central and Northern Caribbean. In fact, if you go far north, it's almost saying there's negligible change in the sea surface temperatures there. Right? We've seen in the Caribbean a rising trend in mean temperatures of about 0.1 degree per decade. Warm days have steadily increased since 1960, where we're seeing 22 more warm days. We're seeing 21 more warm nights since 1960, and cold nights and cold days have decreased to 14 fewer. So, how I typically like to relate this is in Jamaica, we typically talk about Christmas breeze. And I'm going to ask you, if you live within the confines of the corporate area, when was the last time you experienced your Christmas breeze? Right? Pulling something for Jamaica, and again, just showing the temperature variations. Here within the temperature variations, you're looking at something, and this is to visualize the possible changes in distribution of climate and its variability. And we're looking at successive climatological periods And so we're looking at the shift in means as well as the spread and the width of the variability. Each bell distribution that you're looking at represents a 30-year climatological interval. And this helps us to recognize, for example, when years are becoming hotter and or more intense temperatures are occurring and more frequently. So as I push ahead, you realize that there's a shift. The mean distribution is 24.5. In this instance, the mean is 25. And that's going from the 1950s to the 1980s, 1970s to 2000s. And now if I look at 1991 to 2000, it's indicating again another shift, right? And that shift is significant. And it's suggesting that we are getting warmer, and you can see tapering down. So again, the distribution is also spreading out what well. So the maximum temperature is increasing, and the minimum temperature is no longer going as low as it normally did. It's also increasing as well. All right? Within Jamaica, as with the Caribbean, Jamaica has distinct rainfall zones. And there are 4 rainfall zones, with the most amount of rainfall occurring in the Portland region. And we have drier regions towards the south and north, and a semi-wet region in the center, and the second wettest region to the east. All right? There are some key distributed across Jamaica, and you can see that for November, Portland's rainfall tends to be very, very high. And so everything tends to have the same amount of rainfall between July and September. If we're going October to November, that's when Portland tends to get its most amount of rainfall. And in some instances, this can lead to disruption in supplies across parishes. As you can realize that in February, Portland again is getting that high amount of rainfall. And so JPS within that period of time tends to have the greatest disruption in supplies in those northern parishes in and around that point in time. Again, this is January, St. Mary, St. Anne, and again, they're distinctly related to when they receive their highest amounts of rainfall. Right? Again, this is August, and looking at August, you can see that August again is another one of those high periods right across the country. Right? Hurricanes, as small as our country is, we are not, the island doesn't tend to experience hurricanes in the same way. So if you set up a diagram, set up a 50 km radius from the center of each of these grid boxes, what you realize is that Portland Cottage area tends to be the greatest significant area of impact. It experiences 71% the probability of a hurricane passing within the 50 km of that. And the lowest percentages, again, towards the east and to the north. Right? So the Caribbean, we are getting warmer. So the Caribbean recorded its hottest period ever. So 2020 was remarkably the hottest year within the Caribbean, with several of these areas recording the highest amount of highest temperatures ever. So September for Dominica was very bad in 2020, where they recorded the highest temperature for that day was 35.7. On the 14th day of the same month, in the city of Point Salines in Grenada, they also recorded 34 degrees, another absolute record. And just 3 days later, on the 17th of September, in Puerto Rico, they recorded 37.8. And that, again, was a record temperature in that area for 2020. No, overall record. Rainfall, we've seen increases in rainfall. And that increase, not increases, we've seen changes in the variability of rainfall, but can't say anything about the total. When we say changes in the variability, what we mean is that if we're accustomed to getting rain afternoon showers, we're now seeing a greater expanse in how those showers are coming. But if there's not a change in the total, and I'm getting a longer distance between my rainfall periods, it simply means that when rain falls, it's making up for when it never fell. So if you get long periods without rainfall, it means that you're going from a period of heavy rainfall to a period of no rainfall to a period of heavy rainfall, which leads to flooding. There are some impacts towards the shifting in things. It can affect crops. So it can affect coffee production. It can affect water supply. It can lead to pest infiltration. It can have drought condition, can lead to increased expenses for farmers, which results in elevated prices for food. And the key thing to note is within the region, all of these things can be forecast. So there is something called Regional Outlook Forum that specifies 3 months in advance whether or not particular regions are expected to have high amounts of rainfall, low amounts of rainfall. it is quite robust within the region because they tend to do 6 months in advance, and then they do, so every 3 months or every month there's another update of that forecast, because the driving forces behind, how much rainfall, whether or not it's above normal or below normal, is well understood. For rainfall, for hurricanes, and just looking at this hurricane extreme, again, a key thing to note, and I'm just going to highlight it here, is this, right here. So if I'm supposed to look at this, I will tell you that there's a 10% increase in category 1s comparing 1980 to 2000, and that comparing a similar, almost a similar 20-year period, missing 1 year, a similar 20-year period. That's a 10% increase. This is less than a 5% increase. This is a 30% increase, another 30% increase, but this is a 200% increase. It simply means that when we do get hurricanes, it's almost the case that we're going to go through that period where the hurricanes are going to be at the maximum category. So if in the region over a 20-year period, we got 4 major hurricanes, category 5 hurricanes, it's suggesting that we get 1 every 5 years. Now within a similar period, and I have not included 2020, we're at 13. It's almost stretching to the point where we're getting almost 2 a year, getting to the point where it's almost approaching 1 a year, sorry. And that spells disaster. Because if we go and analyze, the impact of Hurricane Ivan on Grenada literally devastated Grenada in a single night. Grenada's GDP was set back by 10 years. Reasoning behind that for me is this. If you know anything about Grenada, it was known as a spice act, predating Hurricane Ivan. And after Hurricane Ivan, they were still known as a spice act, but this is the problem. After Ivan passed and made landfall, every nutmeg tree laid flat. Now, if you know anything about nutmeg, it takes 7 to 10 years for a nutmeg tree to grow, to produce viable commercial supply. And so literally you move from a space where you're you're dominant in the market to a time where you're non-existent in a single night. And so, in essence, you think about it and you say, well, hurricanes, but the hurricanes gain their strength from the warmer oceans. So again, you're tying hurricanes to that. And so you're looking at drought as well. And so, as I said, for the region, tropical diseases are there. In the 1990s, you're looking at the region and you couldn't find that dengue has 4 serotypes. And you look at the Central American and Latin American region, and you realize that it moved from areas with none or no data and not specified to a point where there is not a single nation within Central America and Latin America that doesn't have dengue, and there's not, and majority of them now have all 4 strains, which means that increases the opportunity of actually developing dengue hemorrhagic fever. As I said, it gives us the ability to plan and prepare. Now, given that information, it gives us the ability to prioritize. It gives us the ability to choose what it is that we're going to do. How do we lay out to be robust and resilient? All right, so what about the future? I'm going to wrap this up in the next few slides. Our future is clear. It's suggesting again that we will see a relative decrease in overall change in precipitation. And that decrease in precipitation is going to, in some instances, be as high as 35%. Right? And the further we go into the future, is the greater that decrease is going to be. And that decrease is largely going to be during the period that we expect rainfall to occur. Right? Again, and looking at the region in totality, we can see that the changes in precipitation are greatest in zone 6 and zone 1 and 5. Right? In some instances, the changes can be positive as seen for zones 1 and 3. Right? The temperature, relative change in temperature, again, the greatest changes can be seen in zone 1, zone 6, and zones 2. Right? We're going to experience even higher sea level rise. We're going to experience, our droughts are going to increase. So you're looking at the 2030s, where you get 2, 5, and 10, to the 2060s, where it's now 10, 6, and 10, to the 2090s, where it's 12, 6, and 16. So where extreme droughts remain the same, severe droughts are increasing and moderate droughts are increasing. Right? So the total period that will be under drought, you're moving from 17% to 26% to overall 34%. So there's an overall increase. What we're projecting is that when storms occur, we can't say anything about the number, but what we can say from the projections is that they will have higher rainfall rates and even stronger winds. right? For the region, we're projecting warm days and warm nights and consecutive dry days and nights. This leads to a point where you're looking at it, we're seeing an increase over that period. And in some instances, you're looking at Barbados, there'll be an increase of almost 400% in the number of consecutive dry days. Whereas for Suriname, there'll be a decrease in the number of dry days as they actually get increases in rainfall. Right? Just pulling out some impacts from the future, and you can see that you're projecting based on climate, and this by 2030s, we'll actually experience a 12% decrease in growth rate of maize, 23% decrease growth rate of rice, and this is also including other factors as well, but climate is also a part, due in part to climate change, wheat and other crops. And in each of these instances, it can lead to increases in food prices. Impact as well expands the fisheries, where fishery production and yields within the tropics is going to drop off by about 40%. They projected to drop off by about 40%. Temperature increases of more than 4 degrees will endanger the ability of farms and ecosystems to adapt, and water cycles will vary, will be very different from and less predictable, and changes will also lead to sea level rise and melting. Right? Drought intensifies the risk for heat stroke and complications of heart, lung, and kidney disease, and it can lead to heat stress. Increased exposure to toxic algal blooms. It increases the exposure to toxic algal blooms and pollutants from arsenic and nitrates, and it contributes to stress and anxiety and depression. And we can also talk about water quality, mental health, and a lot. But climate change impacts a wide variety of factors. And at the start, I said to you that it can be related to wildlife. Now, there are reptiles whose gender is heavily dependent on the temperature in which the egg is laid and hatched. Now, can you know that if we keep increasing temperatures without any other expected changes, pretty soon some reptiles will largely be produced being only one gender because they're so temperature sensitive. Right? So wrapping up, we got the ability to plan and prepare, we got the ability to prioritize, and there are some distinct possibilities that need exploring. And with that, we get the ability to plan and prepare for some additional changes, prioritize climate change, and also explore the possibilities of building back better. With that said, and before I wrap up and lead to the thank you, we've designed some tools within the climate space. Within the climate space, we think that climate should not just exist in a climate context. We've designed a tool, again, this is done with Dr. Rankin, and the tool was designed primarily for farmers. And we have 2 or 3 crops within the tool. And before you plant a single crop, you can vary a variety. Before you physically plant, you can click just with, I call it a 5-click model. With 5 clicks, you can actually determine what your yield is going to be like before you plant. It picks the soil type, it can calculate for you how much, what your physical input, money input for fertilizer, water. You can even drought stress test the crop and say, you can pick intervening years. Let's say I have a dry year as I did in the 1970s. Let's say I have a dry year as I did in 2015. Let's say I simulate 2015 climate onto now. It can calculate for you your yield. And what that does, I believe if it starts being used, it engenders food security. So there are some possibilities as well for parameterizing insurance towards certain things, but that's not my area of expertise. I'm largely a climate interface kind of person. So we're going to open the floor for discussions at the end. And I thank you for your time. And I really hope I haven't taken too much of your time.
Okay, thank you very much, Jay, for that very informative presentation. And we'll just jump straight to Jose. Okay, we are seeing your screen, but we're seeing it we're not seeing it in the slide format as yet.
Now?
Okay, yes, we're good now.
Good. Can you hear me well?
Very well.
Okay, I will try to make the presentation in 20 minutes. I will do my best. Let's see. So this section is about the Jamaica cat bond, and also we are going to provide an overview of cat bonds. Also have some points about why a cat bond for Jamaica, while there are other many instruments available, including the CRIP insurance policies. And also, I want to present some of the key features of the cat bond for Jamaica. So first of all, I want to be very clear: the cat bond is no debt. I mean, the name is a kind of little misleading. It's a risk transfer instrument used not only by sovereigns. On the contrary, used mostly by the private insurance and reinsurance companies. So in the case of the sovereigns, the objective is to provide a quick payout for supporting the budget of the government. Again, it's a risk transfer instrument similar to an insurance, to a parametric insurance in particular, and by which the sponsor, the country or the insurance company receives a payout used as quickly as the disaster happens, and of course meet the contractual criteria. This is different for parametric insurance or reinsurance-based or insurance-based parametric insurance, in the sense that the sum insured is fully funded, so there is not credit risk for the other parties. And again, there is not a debt at all for the parties. This is the standard structure used by the World Bank cat bonds. This is not the only, no way, the only option that the sovereign has to have to for having access to these instruments. Instead of the World Bank, it can be used as a private intermediary. They create their own special vehicle purpose, but the flows of the money is pretty similar. So on the left-hand side, we have the client sponsor, that the government state-owned enterprise that happened in the Philippines in the first time, international organizations, funds, and so on. So they are going to make a premium payment of the risk margin to the World Bank, and this premium payment is paid to the investors. Contractually speaking, there is a bond documentation, a standard bond documentation between the World Bank and the investors, and between the clients, the government. Say there is a risk transfer instrument with the World Bank. What is a risk transfer instrument? Could be an insurance wording, a reinsurance wording, could be derivatives, and so on and so forth. So the point is that the party, the counterparty of the government is the World Bank. They are not direct counterparties with investors. In case of a payout, of a trigger event and producing a payout, simply as the World Bank already has in this pocket the full amount of the sum insured, simply pay the payout to the client, and of course the investor loses the money. And basically, this is the scheme. Some of the characteristics and benefits, depending on the underwriting cycle also of the cat bonds, are the following. There is no credit risk because the sum insured is fully funded by the investors. There is an increasing, or used to be an increasing number of ILS investors, basically because of the lack of correlation of catastrophes with the own investment portfolio. So as we can think that the catastrophes, earthquakes, tropical cyclones, and so on and so forth, they are not correlated at all with the economic situation. The cat bonds are signed to cover some particular part, or some particular layers of risk in which the insurance may fall short. For example, for those working with the catastrophe property insurance, you know that for some threshold and above, reinsurance companies, international reinsurance companies, are used to price with a minimum amount, independently of the AAL, of the average annual loss for that particular layer. So that is say that a niche that cat bonds might feel. The pricing and liquidity, this is very transparent and efficient price discovery with investors. And again, even can be some cat bonds, because they are liquid, can be transacted in the secondary markets. A difference to more or less standard insurance and insurance contracts, they are multi-year coverage. Between 2 and 5 years, normally 3 years is the normal, and the price is fixed. This can be a benefit or not. It's going to depend on what happened with on the rating cycle. So it depends. The payouts are quicker than at least the indemnity insurance. Lastly, the usage of the cat bonds in conjunction with the rest of other financing instruments are improving the sovereign credit rating, as was the case for Jamaica. So the market, if you see at the pie graph, the insurance linked security market is composed in the most for US related risk. They are very few from Jamaica, for Japan, and other from Japan and from Mexico, and so on and so forth, some from Europe. But if you see closely, they are very few risks carried by for Latin American countries, or in general by countries around the fire circle. That is very important, because if the Latin American countries in particular are trying to place some of the risk in the ILS market, they are also bringing some diversification to this particular market that is most composed by, as you can see, by US and Japanese risks. Also, important to bear in mind is that the ILS market is really a small one. This is information comes from is totally public and is updated daily. Is from the website of Artemis. So the current yesterday value of the outstanding cat bonds is about $35 billion. So in reality, is not as big as for example the transactions in reinsurance, but it still provides a very interesting and complementing coverage for reinsurance, for other reinsurance coverage. On the pricing, the multiple, I mean how many times the commercial premium is with respect the average annual loss has been after this minimum, I think it was in 2017, has been increasing. Now with the just recent hurricanes hitting precisely the east side of the coast of the US, and the current one, we can expect an increase again in the multiple, but we need to wait for the end of the year in order to see how is the renewal of reinsurance and so on and so forth. But the trend right now is increasing. The World Bank has placed about $3.6 billion in cat bonds, all the history, starting with Mexico in 2009, The biggest transaction was with the Pacific Alliance countries, Chile, Colombia, Mexico, and Peru, 2019, almost in the minimum, with the minimum multiple pricing, and the amount was 1,360 millions. And the last one has been Jamaica. By the way, this just to give you an idea of the size of this transaction. Here we are talking about $3.6 billion in sum insured, say. But for example, in Colombia, with indemnity insurance, traditional indemnity insurance for property, they have insured $40 billion, just to give you an idea of the proportions. Okay, now why cat bonds? Why don't you keep say that with the CRIF or loans, contingent loans, and so on and so forth? First of all, we need to be clear that there is not just one instrument that is going to provide a solution for financing of the disaster risk. One instrument just part of the solution, not the solution. So the first thing that we need to bear in mind, trying to fill the gap, is what is the problem that we are trying to solve, we are trying to finance, and what are the best instruments. In these two questions, we rely almost on a daily basis on the three post-disaster phases that are the relief, the recovery, and the reconstruction. Relief is the money or is the activity that is related with saving lives and protecting assets from further destruction or damage. The recovery refers to the quick reconstruction or replacement of some property. For example, the bridge that is destroyed by the tropical cyclone or by the earthquake, is necessary to quickly put a bailey bridge in order for the support to the people affected to be reachable. And finally, the reconstructions. The first phase, the relief and recovery, basically starts in the moment of the disaster. And if we are talking about drought, for example, that is a long-term disaster, this is going to be a long way for that. But anyway, reconstructions usually starts months, maybe years after the actual event happens, for many reasons, because it's necessary to build back better, so you cannot build the same hospital just on the same seismic fault. You need to find a safer place, and so on and so forth. So we need to be in mind these three post-disaster phases. What is the problem? What is the phase that we are looking for how to finance? That is one. And the other is related to two probabilistic laws. One is about the frequency and the severity. Basically, I mean, while the three post-disaster phases have been identified by the World Bank, basically, and other multilaterals and thinkers, these probabilistic laws start even from the industrial age with the workers' compensation accidents. So basically, what we are found also in natural disaster is that we can find three defined or well-defined layers. One, the first layer is related to highly frequent events, but very minor, less severe. We have a second layer with the least frequent events, but with the impact or the severity is higher. And then we have very infrequent events in which the size of the losses produced are catastrophic. So they are the three layers. And in terms of financing the relief and recovery phases, we can think about the reserve funds, emergency funds, saving funds, this kind of money set aside for dealing with these smaller events, and also with annual budget reallocations. It's not the best thing to do, but in the reality, is a very normal instrument to be used, and is not recommended to use because the government or the country is diverting funds that was allocated for some particular development purpose, and then need to be diverted. For the middle layer, we advocate for contingent lines of credit, like the World Bank KDDO or the Inter-American Development Bank Contingency Credit Line. And finally, for the third layer, we promote a lot the transfer of the risk transfer instrument, parametric insurance and cat bonds and so on and so forth. And on top of that, we need to be aware, we are trying to make the public servants aware that there should be some residual risk. No, every single penny of potential losses can be financed through the retention or transfer that amounts. It don't make any sense, and this could be, and there is no resource for that. So there is some residual risk in which international donors might be necessary, and as usual, even despite of the different set of instruments that are being setting, an increase in debt or an increase in that also can be necessary. For the reconstruction phase, we follow the same approach, of course, applying the probabilities of frequency and severity, but then for more frequent events, less severe, we need to think about reserve funds, and the annual budget allocation is about reconstruction. The contingent lines of credit can also be used, was the case in my country, in Costa Rica, in which KDDO was used for rebuild a small town destroyed by an earthquake. And very important in terms of insurance, indemnity is the recommended instrument. Why? Number one, indemnity insurance don't have the problem of the basic risk, because it's not based on the model, it's based on the actual evaluation of the loss. But of course, they have the characteristic that is delayed because of this necessary evaluation of the risk. But on the other hand, parametric insurance, like the one offered by CRIF or cat bonds, etc., are more appropriate for the relief and recovery phases, because they are designed to provide a quick payment, but they have the problem of the basic risk. We are going to keep talking about that several times. So that is the fundamentals, or two of the fundamentals, why one instrument cannot be the solution, part of the solution, and how these instruments can be ensembled. So there is a reflection of what instrument can be used and also what instrument should not be used. For example, using any form or risk transfer instrument for very frequent events with a small severity is almost trashing the money, no? That is why we have deductibles or priorities and so on and so forth. So each instrument can be maximized in terms of the benefits. That was theory. This is the practice. We actually we don't promote one instrument in particular, but the portfolio of risk retention and transfer instruments that is going to be the most cost effective, and paying attention for the funding needs of these particular for disaster phases. In the case of Jamaica, there are several instruments that take into account precisely that what are the short-term liquidity needs and what are going to be the reconstruction needs. So for the short term, Jamaica they have a contingency fund of $31 million, and also they consider the budget reallocation. In the contingency financing, Jamaica, they have a loan, a contingent credit loan with the Inter-American Development Bank for $255 million. And this loan is parametric. They need to trigger some particular conditions in order for the Jamaica to access the loan. And in the short term, also as many Caribbean countries and now Central American countries, they have tropical cyclone, excess rainfall, and earthquake coverage from CRIF, and the cat bond for the tropical cyclone. On the side of the reconstruction, with respect to public asset insurance, the government of Jamaica has been strengthening the local insurance market, in particular with the reinsurance requirements, and is work in progress in order to improve the insurance of the PPPs. I think that from this slide and the previous one, it should be clear that the cat bond or any other instrument, by the way, is not a substitute of the CRIF insurance coverage. There is a complement between different instruments. And on top of that, given that the cat bonds are not debt, the Fitch rating agency provide this statement with respect to the world sovereign Jamaica debt rating. So it's an excellent notice for the country, and also as the rating agencies are taking more and more into consideration the exposure to natural disaster and climate change, by the way, this kind of financing strategy, this portfolio of instruments are going to be more important for the rating agencies in order to have a look of the sovereign rating. There are several pros and cons on both the parametric insurance of the cat bonds. The CRIF really pays very quickly, maximum of 14 days. That is the practice in all the payouts. The insurance is negotiated yearly. It could be a pros or a con depending on the underwriting cycle. The insurance policy does not have the high transactional costs and legal fees that is normal for cat bonds. That is a very important point to take into account. And the CRIF offer these benefits, the benefit of risk diversification, of the pooling of the risk for all the country clients. On the cat bonds, there is also risk diversification benefits from, but these come most for one country in particular, like it was the case of Jamaica, from the diversification obtained by the investor having, the portfolio, most of U.S. Exposure for tropical cyclone or earthquake, having the Jamaica that is not highly correlated at all with the U.S. So that is a different source, but there is also diversification benefits. The key difference is that the CRIF is a mutual insurance company, so there is not the conflict of interest that is in the textbooks between the policyholder and the company owner. So that is also a benefit. The cons on the CRIF is the basic risk. The parametric insurance is not liquid. So at the end of the day, there are some credit risk from the counterparty, and the parametric insurance is only offered by CRIF SPC. There is not a competition as such for them. I just keep moving because I think that I'm running out of time. So there are a description of the difference of the most used trigger types. In particular, the CRIF trigger is based on the model loss. That means that the model used for pricing is used for making estimation of the loss caused by X event, a tropical cyclone, an earthquake. It is input the physical characteristic, push the button at the end, an X amount is calculated, and based on that and the insurance policy condition, payout is provided or not. The parametric that is triggered, that is the one used for the cat bonds. Here is the physical characteristic that is one to determine if there is a payout or not. In terms of simplicity or for explaining to the population why or why not a payout is happening, definitely the parametric is easier to explain, as the model loss is the result of the running a model that is not publicly available. Also, right now we are working with several countries that are interested in this on evaluating the cat bonds. Other countries, other Caribbean countries, even smaller than Jamaica, the cat bond can be a way to reach different markets, than CRIF, and that might complement the CRIF insurance and other instruments that might have on place. Now, very quickly, I'm going to look at some of the key features of the Jamaica cat bonds. This is just the representation of the graphic representation of the graph that we saw at the very beginning. Again, the World Bank is intermediating between the capital investor and Jamaica. The difference here is that the government of Jamaica received grants from the GRIF, funded basically by the UK and the Germany, now going to be starting as the Global Shield, and also received grants from the USAID. But the transaction is the same as explained before. At the end of the day, after several analysis, the $185 million cat bond was issued, and the coverage is for 2.5 years, covering three hurricane seasons. The World Bank Treasury issued the bond, providing all the services. And again, the Fitch rating issued this particular report on how the transaction, in conjunction with the other instruments, is strengthened the sovereign rating of Jamaica. Some of the key features are the following. There is a question, by the way, on the chat about if we use it. There is a play around, so sorry about that. If we work together with some Jamaican or Caribbean people, and actually one of the key objectives of these cat bonds is we conduct a technical assistance phase that is totally independent of a potential placing of instruments. So, and this technical assistance phase is working hand in hand with the Minister of Finance in particular, because the idea is to deliver all this technical knowledge that is ongoing, and help and provide information and relevant analytics in order to make informed decisions. Okay, I'm trying to answer that question in this way. The actual cat bond for Jamaica is only quoted for tropical cyclone, but we actually evaluate earthquake too. But we found that in the gap analysis, the earthquake was well covered for the emergency and rehabilitation phase. So it was no need at all to have a multi-peril cat bond in the case of Jamaica. All the analytics were based on the AIR CAD modeling services. That company is one of is the lead in particular for this kind of transactions, and is widely known in the insurance and reinsurance markets. The triggers are parametric by design, and we work really hard. We try to do our best in reducing the basis risk. Sometimes we talk about minimization of the basis risk, but as we don't know, we don't have a decent, a robust number of actual events. We actually cannot say that we are in minimization process, mathematically speaking, but for sure we are doing interesting reduction on the basis risk. And how? Basically working on the candidate grid. If you see the bottom graph with the territory of Jamaica, it is divided in a grid, and every cell in that grid is had their own trigger and their own payout pattern. Also, we experiment in the good sense with the CAN model of the benefits of having the trigger based on the accumulative rather than the minimum pressure in each of the cells. And this, if you think this is kind of natural, because if the path of the hurricane or the tropical cyclone cross several of the cells in Jamaica territory, the damage is accumulative. It's not just the maximum damage in one particular cell, it's the accumulation. So based on that, say kind of common sense, we explain this possibility at the government of Jamaica, and the government of Jamaica agreed on that possibility. Also, we push and we work together with the investor in order to ensure the quickest payment that was possible. So we start with several prototypes, just trying to see what are the most appropriate set of boxes or grids for Jamaica. I think we work at least with about 10 prototypes, something like that, but choose the best. Some was trashed almost immediately because of the results. I mean, in terms of the basic risk, and at the end, focus on 5 of them. For each of these cells, we work with different payout functions. This is just an example for one particular. Of course, this is not the last, the final payout function, because that is confidential information, but just to give you an idea. And the characteristics of the cumulative basis of the payouts, as mentioned before. And as mentioned before, these characteristics are defined for each of the cells, and then the CAD modeling agency optimize the characteristics of the trigger, the attachment point, the exhaustion point, and so on and so forth of each of the cells based on particular cells. For example, for Kingston, that there is set as the objective, and then the rest of them are optimized in the way that the whole Jamaica is covered. That is the purpose. So there is explanation of footed enhancement that we made, and the stepwise payout function was also refined, and then in the placing process, it was further refined by the placing agency. So at the end of the day, the CAD bond design is very particular because of the cumulative payouts from all the sets affected by the same tropical cyclone, by the same events. Is parametric with a central pressure defined for each cell in the grid, and the same for the payout function. There was process for discarding some of the prototypes based on some of the actual the side of the market. For example, which kind of prototypes are expected by or want in the right stake, and also of course the basic risk analysis was one of the key say guides in order to discard some and keep others prototypes. We conduct basically two fully stochastic analysis. One is the gap analysis. Basically, we use the loss extended curves for, in this case, tropical cyclone wind in particular, for emergency losses only, and the emergency losses are defined as a percentage of the asset losses produced by the model, and this percentage was defined by the government of Jamaica, based on their own experience and their own expectations. Here, this is a representation of the losses, of the emergency losses again for tropical cyclone, and how the different instruments that we play with in this analysis fill the gap and don't fill the gap. Just to give you an idea, in the case of earthquake, the red part of this figure is pretty small. It's almost is negligible given the instruments that they had. But for tropical cyclone, for these more frequent events, they are very well financed. It's okay. There are still some gaps, of course. This is not perfect coverage. But then for more frequent, less frequent events is where the gap is. So it makes sense to try to put instruments here in these sections with this probability of occurrence. That is how, from a probabilistic point of view, it's demonstrated that the cat bond complements and not substitute the CRIF insurance policies. That was an analysis that we made, and with this analysis, once we put, say, one new instrument or make a change in the order of the different instruments, the question for the decision maker is, with this level of probability of being bankrupt, is okay for you, or you need to less, or you need more? Because also there is part mathematical, but of course there is a matter of the risk aversion of the decision maker. So that is the relevance of this gap is about make a determination of the bankruptcy probability of the government, of meaning running out of the ex-ante instruments that they have defined because of the natural disaster, in this particular by tropical cyclone wind. That is one part of the analysis. The other analysis is related to the cost-benefit analysis or value for money analysis. This is based on this paper that is here. Is of course it's a public paper. This say the basics for this evaluation. This basically dynamic financial analysis, having as a random variable the losses are defined, in this case the emergency losses, and this is a description of the different financing instruments and where is the cost coming from. Even for setting money aside, the reserve funds or the budget allocation, there is opportunity cost, social opportunity cost of having this money parked. I mean, that money can be used for building schools or building hospitals, I don't know. But there is a opportunity cost that we take into account in this calculation of the net present value. Okay. So again, wirecard bonds, we once the gap analysis is done and it is demonstrated the need or not of having a new instrument or a different mixture of instruments, we made the homework or use different strategies or financing strategies. Financing strategy is defined as a set of instruments with a predefined order or uses. So the status quo, we start with the status quo, of course. In this case, for Jamaica, is composed by the emergency funds, the $51 million, the Inter-American Development Bank credit line, contingent credit line, and the CRIF. Okay, and on top, that is the status quo, and then we use different strategies. For example, the second one is to use the money that is expected to use in premium to put it in the contingency bond fund. That is why this is this increase. Or in the third is to have an expanded CRIF insurance policies. Or the other one is to leave the CRIF insurance policies as such with exactly the same emergency fund and use different prototypes of cat bonds. Okay, so they are competing strategies. At the end of the day, based on this analysis and the gap analysis, the best option for several reasons we are going to summarize in the next slides was to place the cat bond for 2.5 years of coverage. So there, that is why the cat bond makes sense in a complementary approach with the other instruments. One is that the basic risk of the strategy was diversified. Jamaica has some basic risks for the parametric insurance with the model loss trigger, with the contingent credit line of the Inter-American Development Bank that is based on number of affected people, and the cat bond that is having a trigger based on central pressure on the grid. We work directly with the Ministry of Finance, the different prototypes. We evaluate the option of having a basis of accumulation versus the maximum win effect, and push for a faster period for the payouts. At the end, a coverage for 2.5 years or 3 hurricane seasons reached $185 million, meaning a leverage of about 25 times. I mean, being the leverage ratio, the sum insured divided by the annual premium, that is not so bad. Is good. And these are the results from the financing gap and the not present value analysis. In particular, we found that just based on the net present value, that is just a number, for this range on the loss extent probabilities between 5 and 1%, the cat bonds, the prototype 2 of the cat bonds and the CRIF expansion were the two best options. For others, ranges in the loss extent curve, the CRIF definitely is the best. And for the more frequent events, the current set of instruments is enough. So we don't need to even to recommend the government of Jamaica to spend money in other instrument for that particular layer of risk. That's the point. So the government wants to increase the protection for this particular layer between 5% and 1%. And given the other benefits provided by the cat bonds, like the basic risk for the wall and diversification of the basic risk for the wall portfolio, and so on and so forth, the decision was to move ahead with the cat bonds. So that is my presentation. Thank you so much for your patience. So at the end of the day, certainly the CAD model and the analytics that can be produced based on that is inform the decision maker, but definitely is not the only aspect to consider. More, if you take into account the uncertainty of the CAD modeling and all the analytics based on that. For example, if you compare that with the modeling of direct damage in automobile insurance, the uncertainty is pretty different. So also the other variables, not necessarily quantifiable, can need to be taken into account. So that's my presentation. Thank you.
All right, thank you very much, Jose. All right, based on where we are at time, I'm just going to only do one question for each. Jay had responded to a number of the questions in the chat. I'm just going to ask him to verbalize his response to the question, which is, the CAA has influence in discussions about risk in the Caribbean, but less so in discussions about climate risk. How do you suggest for improving awareness of our skills and contributions and the contributions that we can make? Okay, maybe having some challenges on his side, so I'll just go ahead and read his response. He says it's a difficult one, but he suggests that we leverage the success of the Climate Studies Group as well as the Caribbean Modeling Consortium, which spans the region. So we are his team, they're seeking to financially quantify all the changes mentioned in the presentation as a next step within their 5-year strategy. And he does think that having sessions like this can be quite helpful. And I will ask Jose just to take the last question that came in. How do you know how much demand is there from investors for bonds for this type?
I mean, as I show in one of the graphs from the Artemis website, the new issuance have been increasing but a lower rate. Basically, I think the appetite for that is there. I mean, from investors, but as many capital markets have been impacted by the pandemic and by the war. So there is a reduction, I think, in my view, of the liquidity of the ILS markets. Nevertheless, I think that once these situations start being normalizing or reducing the impact, the benefits of diversification of the cat bonds to the investor are there. I mean, this is not going to disappear, and there is a good reason for investor to keep putting money in that. Yes, and also remember that catastrophe reinsurance is an excellent line of business. It's a very profitable line of business as long as the reinsurance company has a very diversified portfolio. So that principle also should apply to the ILS market, to investors. And I think that the entrance of other sovereigns I mean, other than US or Japan, is going to attract more and more investors because of the the embedded diversification benefit that they bring.
Okay, thank you very much. I'd like to thank everyone for joining us this afternoon for this Lunch and Learn session. Thank you for staying with us, and I'd like to give special thanks to our speakers, Jay and Jose, for being with us and for definitely giving us a lot to feed on. As mentioned earlier, this session was recorded, and you can find it later on our social media pages, as well as ActiveView and YouTube. There was a question earlier about the actual presentations from the speakers. I'll get back to you on that one, but thanks again, everyone, and hope you do enjoy the rest of your day.